Okay, this is a June 2014 question 4 question on moment. The diagram shows a uniform rod AB, length 1.8, mass 3 kilograms, and it's held in equilibrium horizontally by two fixed cylinders C and D. An object of mass 12 rests at B. AC is 0.3 and CD is 0.4. The force exerted on the rod by each of the cylinders is vertical. Find the magnitude of each of the forces exerted on the rod by the cylinder. So whenever your question is, first thing you should be doing is putting on all of the forces on the diagram. Okay, with a sharp pencil. So we've got, at C, if there's an object on top of it, the reaction acts down. If there's an object below, the reaction acts up. So we can call it a reaction at D and reaction at C. We've got a mass of 3 kilograms of the rod, the length of 1.8 meters. Held in equilibrium, object of mass 12B, so that's 12G coming down. The length AC is 0.3 and CD is 0.4. Okay, see what else we can put on here then. So we've got the mass of the rod is 3 kilograms. It's a uniform rod, so that means the mass acts at the centre. So you put 3G at the centre there. The length of the rod is 1.8. Now if this is at the centre, half of 1.8 is 0.9. So we know that this distance here is 0.9. Okay. Half of it is 0.9, so this adds up to 0.7. So this little part here is 0.2. Okay. Now then, we are trying to find each of the forces. So that means we're trying to find these two forces here on the cylinders, reaction at C and reaction at D. So the first thing I'm going to do is take moments, and I'm going to take moments about C, because if you take moments about C, that eliminates this reaction at C, because moment equals force times distance. The distance from C here is 0, so that is going to disappear. So take moments about C. So we're going to do it in equilibrium, so clockwise moments equal anti-clockwise moments. So from C, remember thinking it going down this way, so the force is coming clockwise is 3G times by the distance to C is 0.6, plus we also got this force coming down, which is 12G, times by the distance to C, which is 0.9, 1.1, 1.5. That's the only forces coming down clockwise. The forces going anti-clockwise is this one here, the reaction at D. Distance is 0.4. Remember, like I said, the one at C disappears. Then all you got to do is just work this out. Okay, we're trying to find out what this reaction is. So typing this in, you can either leave it in G or work it out. So you've got 17.64. 176.4 equals 0.4 RD. Collect this up and divide by 0.4 will give you RD is 485.1 newtons. So then we've got the first force. Each of the forces, we've got the first one. Then all we need to do is we then need to find RC. So for this, we're going to need to use resolving vertically. This time then, forces up equal forces down. Okay, and the forces we got going up are RD. Forces going down is RC, 3G and 12G. Okay, so you can either collect up the G's or you can work them out. So we've got RD, we already know, we worked out up here, was 485.1. RC we don't know. 3G is 29.4. So that should be a plus there. Plus 12G is 117.6. Collect these up, take them over. So remember RC equals 338.1 newtons. There's the answers.